Hi, my name is Azim bin Ramlan. In this presentation, I would like to talk about a very fascinating topic in semiconductor and optoelectronic devices, which is laser diode. To begin these presentations, let us first know who is one of the creator of laser diode. The laser diode was invented by two independent researchers, Robert N. Hall and Nick Honnoyak Jr. Robert N. Hall, a physicist and electrical engineer, was working at General Electric's Research and Development Center in New York when he developed the very first semiconductor laser in 1962. Hall's innovation was to use a p-n junction in a gallium arsenide crystal to create a pump laser, which also could produce coherent light. At the same time, Nick Honnoyak Jr., an engineer at General Electric's Syracuse facility, he was also working on creating a semiconductor laser. Nick's laser, which he developed in 1962, used a p-n junction in a gallium arsenide phosphide crystal. His laser was the very first to emit visible light, specifically red light. Both of these persons' contribution to the development of the laser diode were groundbreaking, and their work paved the way for so many important applications of the laser, including in telecommunications, medicines, and industry. Before we discuss further about laser diode, I would like to talk more about diode and what a diode is and how it works. A diode is a semiconductor device with two terminals typically allowing the flow of current in one direction. This one-way only flow is a result of interaction between two regions between the diode. In this p-n junction picture, we can see that there are two types of regions, which is p-type regions and n-type regions. While both regions made of semiconductor material, they are each doped with an extra different material causing it to be charged. P-type regions is positively charged and n-type regions is negatively charged. And for the next figure, we can see that this is the periodic table of the elements, and it shows that PN diodes are mostly made of single elements of semiconductor, such as silicons or germanium. PIN diodes are made of compound semiconductor materials such as gallium arsenide, indium phosphide, gallium antimonide, or gallium nitride. So we already discussed about diode and understand how it works. So right now I would like to further discuss about laser diode. So what is a laser diode? A laser diode is an optoelectronic device which converts electrical energy into light energy to produce high intensity coherent light. In a laser diode, the p-n junction of the semiconductor diode acts as the laser medium or active medium. The working of the laser diode is actually very similar to the light emitting diode, or also known as LED. But the main difference between LED and laser diode is that the LED emits incoherent light, whereas the laser diode emits coherent light. As we already discussed that we have different type of compound semiconductor material, but for this presentation, we only want to focus on gallium arsenide. So for these laser diode constructions, the laser diode is made of two doped gallium arsenide layers. One doped gallium arsenide layers will produce an N-type semiconductor, whereas another doped gallium arsenide layer will produce a P-type semiconductor. In a laser diode, selenium, aluminum, and silicons can be used as doping agents. By adding a small percentage of foreign atoms into the intrinsic semiconductor, we can produce two types of semiconductor, which is p-type semiconductor and n-type semiconductor. If pentavalent impurities are added to the intrinsic or pure semiconductor, an n-type semiconductor is produced. In n-type semiconductor, free electrons are the majority charge carriers, whereas holes are the minority charge carriers. So therefore, we can say that free electrons carry most of the electric current in n-type semiconductor. If trivalent impurities are added to the pure semiconductor, a p-type semiconductor will be produced. In p-type semiconductor, holes are the majority charge carriers, whereas free electrons are the minority charge carriers. So therefore, we can say that holes carry most of the electric currents in p-type semiconductor. In this slide, I will talk about how the laser diode works. So based on this picture, we can see that if we apply a DC voltage across the laser diode, the free electrons move across the junction region from the N-type material to the P-type material. In this process, some electrons will directly interact with the valence electrons and excite them to the higher energy level, whereas some other electrons will recombine with the holes in the P-type semiconductor and releases energy in the form of light. This process of emission is called as spontaneous emissions. The photons generated due to these spontaneous emissions will travel through the junction region and stimulate the excited electrons, or also known as free electrons. As a result, more photons are released. This process of light or photons emission is called as stimulated emissions. In this picture, we can see that the structure of laser diode. So basically, laser diode consists of two mirrors, and both of these mirrors are optically reflective. One end is fully reflective, whereas another end is partially reflective. The fully reflective end will reflect the light completely, whereas the partially reflective end will reflect most part of light but allows a very small amount of light. The light generated in the p-n junction will bounce back and forth hundreds of times between the two reflective surfaces. As a result, an enormous optical gain is achieved. As we already know, there are plenty of applications that use laser diode in real life. For example, in medicines, we can use laser diode in bloodless surgery, cancer treatments, eyes lens, and also cosmetic treatment. In communications, we can use laser diode in underwater, space, satellite, and also long distance. And of course, in science and technology, the laser diode can be used for detecting earthquakes, underwater nuclear blasts, and also computer printers. That's all from me. I hope you enjoyed this video and thank you for watching.